12-factor app best practices for Scala deployment. Is there anybody here who has ever deployed their code to production? I hope somebody has, unless they're students. How about anybody today? Did anybody deploy today? Oh, man, I'm sorry. Oh, very good, very good. One step. So deployment's just one of those things that we all do, but nobody likes to talk about it. So I'm going to talk about it today. I'm going to talk about how to do it well and how to do it in the modern era. And I say the modern era because in the last 10 years or so, a lot has changed in the web and in computers, and our deployments have needed to change with them. So 2005, if you were deploying an app on the JVM, you were probably packaging a WAR file. I don't think there was pretty much any other way. But today, the trend is towards executable jar files, bootable jar files. Those WAR files were being deployed into application servers, or at the very least, some kind of servlet container. Very heavy JBoss WebSphere type things, and people still do that, but the trend now, at least, is towards smaller microservices, although now I hear monoliths are back in, who knows. It used to be all about hot deployment, the idea that you could keep this JVM running forever, redeploy your app into it, but memory leaks, permgen, system crashes, system updates, it was kind of a lofty goal. So now the trend is towards continuous delivery, continuous deployment, and reducing the feedback loop or the time between iterations for deploying your code to production. And in 2005, I think pretty much everybody that was writing for the JVM was writing Java code, and today I suspect some of you are writing Scala code. That's certainly true where I work. The most popular language at Heroku is still Java, but Scala is a close second, and it's growing, depending on how you measure it, it's growing faster than Java. So it's been a very important part of our product. My name's Joe Kutner. I go by Codefinger on Twitter, IRC, all the internet places. And I work at Heroku. I'm the JVM platform owner. So Heroku, if you're not familiar with it, is a platform as a service for building, deploying, and scaling your applications in the cloud without managing any kind of infrastructure, even virtual infrastructure. You bring your code, and we handle that for you. In fact, Heroku is considered sort of the first platform as a service, kind of defined the genre. It started with Ruby on Rails and has since branched out to other languages, including Java and all the JVM languages. And so that is my responsibility at Heroku. I am the JVM platform owner, so I'm in charge of making sure that the JVM functions well on our platform, that it works, that it's performant, as well as all the relevant frameworks and the tools that are used to deploy, that they sort of fit into the ecosystem. So I work with literally thousands of Scala applications, and most of those are deployed on a daily basis, and of those, many of them are deployed several times a day. So continuous delivery is something that we really encourage on our platform. So as a result, I see lots of problems, because usually if they come to my desk, it's gotten pretty severe. But I actually consider that sort of a virtue, because I've been able to witness not only the problems, but the ultimate solutions, and have really come to understand why some things work, why some things work well, and why some things just tend to result in problems. So at Heroku, we've sort of compiled all of that, what we've learned from working with these thousands of applications, into a sort of general methodology that we call the 12-factor app. It's a language-agnostic methodology. It applies to any kind of JVM language or non-JVM language. But today I'll talk about it specifically as it relates to Scala. The goals of this methodology are scalability, maintainability, and portability. So this is not something that applies only to Heroku. It applies to all cloud platforms, all deployment platforms, really. So the way in which the 12-factor app achieves these things is through immutability, immutable infrastructure, ephemerality, ephemeral apps, the expectation that your application processes will not be permanent, that things will be disposed of, declarative formats, declarative configurations, and then automating all the things as much as you can. So these are words, maybe ways you would describe the code you write, but I think they should also be ways that you describe your deployment process. And that'll ultimately lead to a more sound deployment. Now, the way we're going to achieve these things is with a tool called SBT Native Packager. So this is an SBT plugin, and if you're using the Play framework, I think 2.2 or later, you're already using SBT Native Packager. But if you aren't using Play, this is how you include it in your project. Pretty straightforward. I think it's at 1.0 now, but this is sort of the minimum version that you'll want. Now, this is not going to be a talk about SBT Native Packager. There's actually a talk about SBT Native Packager later this afternoon that I think will be a great supplement or add-on to this talk. What SBT Native Packager does is it introduces a stage task to your SBT build. And this stage task is really the entry point for deployment for a 12-factor app. So I'm not going to talk in great detail about SBT Native Packager, but I'll continue to reference this stage task throughout the talk. Okay, so without further ado, here are the 12 factors. Soak them up, memorize them. Thank you. I think maybe if I'd done that 5 minutes later, I would have sold it. Okay, no, you don't have to memorize these. They're not going to be on the final exam. I'll go through them one by one. They're a set of principles and best practices, all relating to different aspects of your code. So the first one is code base. This is a principle that states you should be using version control. Now, I know what you're thinking. You're thinking, this talk is going to be about stuff I already know. And this would be a good time to get up and quietly leave. But don't sit down. Just don't leave. I'm going to tell you new and interesting things, but I have to say some things because, people still do bad stuff. So you need to use version control, but you need to use it in the right way as well. And specifically, one version control repository per application. This is the right way to use version control. Of course, you don't want to manually fork your repository and deploy it multiple times. Now, you can deploy to multiple environments from the same code base, of course. What you don't want to do is deploy the same code base to two independent applications. Where I see this violated most commonly is with SBT subprojects. So SBT subprojects allow you to isolate parts of your code and create little libraries that you can package into jar files and share amongst applications. And that's fine. Where it becomes a problem is when you start to include independent or discrete applications as a subproject. And this is problematic because it starts to blend the commit history of these applications. Makes it difficult to identify what commits target a particular application that may have caused a particular problem. It makes rollbacks nearly impossible, and it just generally breaks down the clean interfaces between these applications. Now, you can still use SBT subprojects for your different applications, but the proper way to do it is with Git submodules. So you can run a command like git submodule add, and then give it an independent repository, and Git will actually use that repository to create a subdirectory within your project, as well as a .git modules file that describes that repository. And you can then use your SBT tools to automate the multiple applications. But you retain these independent commit histories. So the two projects have their own Git commit hash, and you can deploy them independently or together. This is good because it allows you to manage dependencies between these, potentially without putting jar files up in a public repository or something like that. And that's important because dependencies should be managed. So in the 12-factor app, do not check jar files into Git. I know, that's another one. But we've all probably done it, right? It's easy to do, and it saves a lot of time occasionally. But it's a bad practice. And it's a bad practice because it results in that dependency becoming unmanaged. So in the 12-factor app, all dependencies should be explicitly declared and managed and isolated. And you should never rely on the implicit existence of system-wide packages. So things like app packages that you might shell out to or something like that. But also your .m2 or .iv directory. Now, these are great for development where you don't have to download the internet when you start working on a new application. But in production, your dependencies for your application should be isolated, and they should be stored in sort of a package, and specifically your target directory. So moving these dependencies from a global repository into your target directory is a process called vendoring. And this is a good thing. A lot of other languages that do vendoring, like Python and Ruby, actually have a vendor directory for these kind of assets, these dependencies. Now, when you use SBT Native Packager and you run that SBT stage task, one of the things it does is vendor your dependencies. So it takes whatever jar files you're using, puts them into this target universal stage directory, which it represents the package that you're going to deploy for your application. And within that is a lib directory that contains your isolated jar files. Now, dependencies are a type of configuration, and that kind of brings me to the next factor. Configuration, don't check your passwords into Git. Now, I know you think that's a duh, but this is probably the most commonly violated principle that I see. Now, you wouldn't check your own personal password into Git, I presume, but would you check database credentials, Amazon, Twitter keys? I see that kind of thing very often, and it ultimately results in maintainability problems and portability problems. So here's a good litmus test. Can you open source your application at any moment without compromising the credentials to any of your systems? I'm not saying you should open source your application, but if you were to, would it be safe? Now, to be specific about the kind of configuration that I'm talking about, it's anything that changes between deployment environments. So resource handles to databases, memcached, external services like Amazon and Twitter, and then per deployment values, like a host name. But it does not include things like your conf routes file or your dependencies. Those are things that should stay the same between different deployment environments. The things that change between environments should be stored in the environment, specifically as environment variables. So configuration should be strictly separated from your code. It doesn't belong in the application, it belongs in the environment. The reason you want to store these things in the environment is that if you need to deploy your application to a new environment or maybe to a new developer's machine, you should not need to change the code in order to do that. Your code should be portable without adding new credentials and some kind of configuration file. So when you store this type of configuration in the environment, you can then extract it if you're using play in your application.conf in this way, with this sort of syntax. This allows you to very easily swap out your database, use a different database for different environments, if you're doing restores and that kinds of thing. All you're looking for is that database URL. So this is actually a good example of the next factor, which is backing services. In the 12-factor app, all of your backing services should be treated as attachable resources, and they should be attached via a URL that is stored in your environment. So that is exactly this. The reason that this is important is, as I said before, it makes your app more portable. It allows you to swap out these services, whether it's for testing or backups or restores. All right, so the next factor before I do a little demo and show how all this kind of comes together is build, release, and run. So this is a principle that states your application should have 3 discrete steps when you deploy to a production environment. Build, in which you compile your code, package everything up into some kind of artifacts. Release, in which you combine those artifacts with the configuration for a particular environment, which, of course, the configuration should be separated from the code, which results in the creation of some kind of release image or release package. If you're using Docker, that would be your Docker image. If you're using Heroku, this will be your slug file. And then finally, run, in which the platform you're deploying to starts up your application from that release image. So using SBT Native Packager and Heroku as an example, the build is started with SBT stage, which compiles your code, creates that package, vendors your dependencies. Release, if you're using the SBT Heroku plugin, is SBT deploy Heroku, which takes those SBT Native Packager artifacts, combines them with the configuration for the Heroku environment, and pushes it up to Heroku. And then finally, run. Heroku will know how to run your application by virtue of using SBT Native Packager, which creates a bin script that launches your application. This bin script knows how to load your class path with the vendor dependencies, and it knows your main class and that kind of thing. this is the right way to run an app in production. This is the wrong way to run an app in production. I see it a lot. I see a lot of people doing this. SBT run, activator run, but I would even say SBT start is also the wrong way to run an app in production. And that's because SBT is a build tool. Oh, it's simple, allegedly. But as a build tool, it's like a parent getting a kid ready for college, right? And then you send it off into the real world, and it doesn't need you anymore. That's what build tools are for. If you're running your application in production with a tool like SBT, it's adding a layer of complexity, indirection, that just makes things difficult to diagnose when problems happen. So don't use SBT in production. All right, so those first set of factors are all kind of tied together as part of the process of packaging your code and getting it out there into the world. So I'm going to show you what that looks like with Heroku. Okay, so I don't do live code demos. I make way too many mistakes. So I've pre-recorded a demo for you for your own safety. All right, so what I have here is a very simple play application. Nothing, I think it's just the one that was generated by default. So I run this application in development with SBT run, which resolves dependencies, binds to a port, and then when I open it up in a browser, it will sort of lazily compile my code, right? In development mode. Okay, good. Now, if I want to prepare this application for production, I would run the SBT stage task, which will precompile all of my code, package it up into that target universal stage directory, vendor my dependencies, and create that bin script for me. So when that process finishes, I can take a look at that target universal stage directory, and you'll see there's the conf directory, the lib, bin, all that stuff. Inside of the bin directory is my app is called Scala Days. It's very appropriate. That's used to launch it on *Nix, and then scaladays.bat will launch it on Windows. Those are all prepared for me. In the lib directory, again, are all of my jar files. So I have this isolated package. And I can run this app in production using that bin script on my Mac, and it'll launch bind to a port. And then when I view it in a browser, I'll see that it's now in production mode. It's not in development mode anymore. So all that little pretty play stuff is gone. Okay, so I can take this application because I'm able to package it with SBT native packager. That means I can very easily deploy it to a cloud platform like Heroku. So the first thing I would do is using the Heroku command line tool belt, create a new Heroku application, which provisions, I'll call it Scala Days EU, which provisions an app on Heroku ready for me to deploy to. We support a number of different ways of deploying to this app. The one I'll show is with the SBT plugin. So I run SBT deploy Heroku. This will take that SBT native packager package, combine it with my configuration for the environment that I'm deploying to, and then package it into what we call a slug file. This slug file represents the entire application, everything that my application needs to run, including the JVM. It's a completely independent sort of image. And it's actually very, very similar to a Docker image, and in the way that it's used to launch multiple processes from this same image. And in fact, Heroku is a container system, very much like Docker, except we use LXC, and we've been doing it for almost 10 years, so slightly more mature. But so you can see from that image, now that it's been launched successfully, I have started Heroku has automatically started for me a single process, and you can see it new to run my Scala Days bin script. And there's my Web 1 process starting up. I can use Heroku logs to check in on the output of that process with -t to tail the logs. And there you can see basically the same output we saw locally, netty's binding to a port. So it's ready to go. We can open it with Heroku Open, and we'll see it in the browser, same way we did locally. This time, though, it's running in the cloud. All right, so now that we have this successful image that's been launched into what we call a dyno, which is essentially a highly isolated process, We can scale our application up by creating more of these dynos using the ps command. If I say web equals 5, that'll give me 5 web processes. So if I run Heroku ps again, I'll see there's my original web 1 process. It's already up and running and handling requests. And then 4 new processes are starting up. And when they've started up, they'll be introduced into the pool, and the Heroku router will include them in its load balancing. I can scale down just as easily with the same command. Down to 1. So this is what most of our customers are doing on a regular basis. They anticipate load, scale up. Let's say they're having a sale at noon. They'll introduce more dynos, and when that sale is done, they'll discard those dynos, scale back down so they don't have to pay for them, give them back to us. Because the application has been packaged in this way into this image, it makes that very easy to do. All right, I'll show you just a couple more commands from the Heroku tool belt. Heroku releases shows you a history of your deployments. So each time you deploy or create a new deployment, you get a new slug file, and we version those for you. So if you deploy something that breaks, you can easily roll back to a previous version and debug that problematic slug offline. And then finally, you can also run commands on the Heroku platform using Heroku Run. So I'll run a Scala console, Heroku Run console, which will start up a Scala REPL on Heroku's server from your application. So you can, from here, do Scala things. With your application, you can import your classes, libraries, and potentially run one-off jobs, one-off tasks. Yeah, I should have included something more specific to this app. Okay, that is the demo. All right, so just to recap, I ran SBT stage to prepare my application for production, SBT deploy Heroku to prepare the release. This could be substituted with whatever your mechanism is. When it is received into the cloud, it is launched from that image, run with that bin script. And then finally, I showed a couple other things, logs, scaling, releases, and remote one-off tasks. Okay, so that first set of factors, as I said, kind of relates to the process of deployment. This next set of factors is related in its own way, but it's more to the architecture of your application, how you design the application itself. So the first factor is processes. In the 12-factor app, your processes should be stateless. They should not hang on to any session state or use thread local or anything like that. A good example of violating this factor is sticky sessions, which are used heavily by the Lyft framework. Now, I'm not picking on the Lyft framework. I mean, that's fine. They've made a decision, these trade-offs. But it's important to understand the consequences of those trade-offs. When using sticky sessions, if a user creates a new session, they're routed to a particular process, an instance of your application, and from then on, they will continue to be routed to that process. The consequence of that is if you want to scale, like I just showed, scaling up very quickly and then scaling back down, when you discard those instances, you're discarding your user's state, your user's sessions. And personally, I don't like it when people discard my sessions. So it makes that ability to scale more difficult. All right, the next factor is port binding. The 12-factor app is completely self-contained, and it exports HTTP services by binding to a port. What's key here is that it does this itself. It doesn't rely on any other piece of infrastructure to bind to a port for it. So what I'm referring to really is that traditional model of JVM deployment, where you package your code into a WAR file, and then you drop it into this running container that has already bound to a port and is sort of trafficking requests to you, and occasionally injects dependencies and things into you. This old way of doing things, it predates the cloud. It predates virtualization. The reason this model of deployment exists is because at the time we were doing this, maybe 2005 and earlier on, we were deploying, in most cases, to a piece of metal in a closet down the hallway. So we needed some layer of abstraction, some kind of container for our application. And that's what Tomcat and JBoss and these things provided. But in the modern era, that's no longer needed. We have new technologies. Resources are cheap. And the modern method of deployment is to package your application into a jar file or set of jar files that can be launched on their own without any other infrastructure except a JVM. And then they can be deployed anywhere, into the cloud, a new developer's machine. It doesn't matter because the only dependency of those jar files is a JVM. And that is the real beauty of doing JVM programming. The ability to be that portable is really unique to our platform in many ways. I work with people on my team that do support Python applications, that support Node and Ruby applications, and they deal with native dependencies, C code that has to be compiled before the application can run, and that's just something we don't typically do, and we should take advantage of that. I'll come back to this. I'm going to harp on why war files are dead again. All right, so the next factor is concurrency. I know what you're thinking. I got this, bro. Like, Scala's good at scaling, right? And indeed, if you are writing your code well, it's great at scaling up. You can throw CPU and memory at the JVM all day long, and it's going to do great. But you also need to be able to scale out, and both in creating new instances of your application processes, which should be feasible if they're stateless, but also in diversifying your workload so that you can scale different aspects of your application independently. If you need to handle more web requests, you should be able to scale the part of your application that handles web requests without scaling the part that's doing background jobs or whatever. Now, this could be interpreted as me advocating for microservices. That's fine if you want to take it that way, but that's really not what I'm getting at. I think the microservices idea is something that, even if you're not fully embracing it, there are these principles that we should all adopt, that we should all embrace, whether we're sort of all in on microservices or not. And the idea of decomposing your application into distinct applications that can be scaled independently is one of those principles. All right, the next factor, which will also draw on microservices, is disposability. This is a principle that states your application should be quick to start up, graceful to shut down, and resilient to failure. So quick to start up, you should strive to get your application starting in under 30 seconds. It should be graceful to shut down if it receives a termination signal. It should cleanly close off all connections and leave no residue behind. And then resilient to failure, meaning if an application crashes for whatever reason, it should be easy to replace, both because it has cleaned itself up and because it starts up quickly. So this really gets to a point, an analogy. I don't know who first made this analogy, but servers are not pets. In that old traditional model of deployment where we were hot deploying and we had these application servers, our application server was a pet. We loved it. And if it got sick, we took it to the doctor and we made sure it could live forever because we don't want to bury it in the backyard. But they're not pets. Our servers are cattle. When we need new servers, we go to the market and we get them. If they're sick, we kill them. If we don't need them anymore, we sell them, right? So this idea of treating servers as a sort of a commodity is really essential to disposability. Application servers are not disposable. They're a big, heavy piece of infrastructure that you rely on to be present. And if something goes wrong with that piece of infrastructure, it could be because of another application running in that same container. It's going to bring your application down. It's going to be difficult to replace because they take forever to start up and so on. Microservices are disposable. They're easy to replace, easy to modify, and they're decoupled from external infrastructure. So again, whether you're really all in on microservices or not, these sort of principles that you derive from this concept are still important. And of course, that's what a whole bunch of folks are learning and talking about. All right, the next factor is dev prod parity. So in the 12-factor app, you should strive for your development environment to be identical to your production environment and identical to every environment in between. The most common place I see this violated is at the database layer. So if you're using Postgres in production, you should be using Postgres in development, not an in-memory database or something like that. It's important not only for making sure you're not introducing unforeseen bugs into production, but also because it makes your application more easy to reproduce, and that leads to better portability. I also see this violated at the container layer very often. If you're using Jetty in production, you should be using Jetty in development. But hey, why even use a container, all right? Containerless applications, bootable jar files are the way things are going. And that's what we're seeing from pretty much all of the modern JVM frameworks, Spring with its Spring Boot, Play, Finagle, Dropwizard. Now, don't mistake this principle of parity for a convenience. I have found that there's a high correlation between apps that are easy to reproduce in a development environment and their scalability, their disposability, these other principles that are so important. So really this dev-prod parity, it's important for ensuring that you can get new people on your team up and running very quickly, but it's also important, it's also a sort of a first step in achieving these more important, I don't want to say more important, but these other 12 factors. So parity leads to reproducibility, which ultimately leads to disposability, because if you can reproduce your application easily, then you can replace crashed instances, you can deploy to new environments, etc. Okay, I'm going to skip over logs. It's an interesting factor, but sort of orthogonal to all these other ones, and jump to admin processes. So admin processes, one-off tasks, for example, a database migration, running your evolution, something like that, they should be run in isolated processes. You should not be logging into a production server to run these kinds of one-off tasks. You'll be stealing resources from a running application. You may potentially crash that application. I'm speaking from experience. And vice versa, too. These things can affect your application. So when I ran Heroku Run Console earlier, I was given an entirely new environment, a new isolated container for my application that I could still have my entire context, my class path, access to my external resources, all of that. In the exact same way that when I scaled up my web processes, I was given a new process derived from that image. The only difference is that with the admin processes, that web process was never kicked off, and it was never included into the pool that the load balancer was routing requests to. But it's identical to those other processes, giving me that isolation. Now, you may wonder why I ran Heroku Run Console instead of SPT Console, and that's because SPT is a build tool, not a production run your one-off task tool. The console task, if this is necessary, 7.0.7.6 is necessary to get that feature. When I ran the console, what I was doing was running my bin script, but instead of launching it with the default main method, I was just giving it a different main method. So it's using the same class path, the same attachable resources, the same JVM settings, but this time with the main generic runner, which is the entry point for that Scala console. I can do the same thing, not only with Scala libraries, but with my own libraries. So I can launch custom worker processes by giving that bin script my worker classes and potentially setting up the JVM options or class path slightly differently. All right, so that is the 12 factors. Code base, use version control, but use one version control repository per application. Use submodules, Git submodules if you need to combine them for automation purposes. Your dependencies should be explicitly managed and isolated. Don't depend on the existence of system-wide packages. Your configuration should be declarative. It should be separated from the environment, and it should, or separated from your application and stored in the environment, specifically as environment variables. Your backing services should be treated as attachable resources so that they can be swapped out or set differently for different environments. You should be able to deploy in 3 discrete steps: build, release, and run. Your processes should be stateless. Port binding should be done by the application, not by some other piece of infrastructure. Concurrency, you should be able to scale up as well as out. Your application should be disposable, quick to start up, ideally less than 30 seconds, graceful to shut down, and resilient to failure. The 12-factor app achieves dev-prod parity. And admin processes, your one-off tasks, should be run in isolated containers and isolated processes. You can learn more about the 12-factor app at 12factor.net. That is our sort of manifesto of these 12 factors. It's also language agnostic, so you're not going to find little tidbits about Scala in there. You'll find more general descriptions of these principles. On my blog, though, I have started basically what I've talked about today, putting in, sort of translating those agnostic principles into Scala-specific ones. All right, so you know the 12-factor app. Congratulations. What do you do about it? Here are 4 things that you can do. Add SBT native packager to your application. As I said, if you're using Play 2.2 or later, you're done. Good job. Once you have SBT native packager, if you're not using Play, you'll probably need to add like a single line to your build SBT and potentially define the main class. Once you have it set up, you can then run SBT stage, and that should generate that package for you. Maybe try and get that running locally just by running that bin script. Should be no other requirements. And then third, deploy to somewhere. Once you have that package, maybe deploy it to Heroku. It's certainly easy and free. Just to ensure that that package is truly isolated, that your application can be deployed from that contained package. And then fourth, go to the SBT native packager talk this afternoon. I think it's called Write Once, Deploy Anywhere. I think it'll be a great supplement to this talk. Again, my name is Joe Kutner. I go by Codefinger on the internets, and I work at Heroku. And my slides are on the web. And mandatory applause. All right, questions?
So you stressed Heroku environment as part of your regular source tree. But it still needs to be version somewhere, I assume. So the question is, where do you put it?
So Heroku versions them for, like, Heroku as an example. Those environment variables are versioned as part of your release. So when you deploy to Heroku, you get a new slug file, or, well, it's more than just a slug file, but it's when I ran Heroku releases and you saw that history, that contains not only your application code, your binaries, but also your configuration. So that release, that's what I'm talking about. If you're using Docker, it's everything in the Docker file, all the descriptors. So it's separated from the code, but you're right, it's still versioned in some way. But how you do that depends really on the platform that you're deploying to. No, it needs to be part of the environment. So you don't share the configuration by sharing the code. You share the configuration by sharing the environment. So that configuration is bound to the environment. And so if ops needs it, if they have access to that environment, they should have access, by virtue of having access to that environment, access to the configuration. So it may depend on another mechanism, yes, but it should still be separated. Yeah, I think that's true to some degree. So I think in many ways, like as with good code, though, the configuration can speak for itself. So you can look at a particular environment and see that, oh, these are the database URL, the memcache URL, and those need to exist in all environments. But yeah, I would agree. Documentation is definitely a part of that. Because each of those instances are running on a distinct port. They're not even, so they're running inside of a container, which is very similar to like a Docker container. So it's an isolated environment that has its own set of ports. It may happen to exist on the same machine as one of your other dynos, but not necessarily. That's not a guarantee. But each dyno on Heroku has its own port that it's given, and that's actually set as an environment variable, your port environment variable. So rather than binding to 9,000, you bind to the port environment variable that Heroku gives you.
So Heroku gives you that?
Yeah. Mm-hmm. And then because if you're using Play, which uses netty, it's just a -d http.port equals, and then the port environment variable. Yeah, is that? Oh, it creates the Uber jar. Yeah, I've seen. I know people that do that, and that's very similar to like what Closure Apps do with their Uber jar with Spring Boot, this executable jar file. That certainly makes it easier to deploy your application if it's completely contained in a single jar file. We just provide the tooling on Heroku. We provide the tooling that the universal SBT package, which is just a directory, is sufficient. But yeah, the more sort of well-bound your package is, I think the more portable and easier to deploy it is. So I haven't used it myself. I know there are people using it on Heroku. So anyone else? Yeah.
This continuous integration stuff. I mean, going from your own development environment to production, that seems like a no.
Yeah, no, and that's definitely not what I'm sort of recommending. But what most of our customers are doing is having a set of instances for development, and just to either validate that what they're seeing locally is also what they'll see on Heroku because they have parity between the different environments. But then, yes, automating the deployment from a CI server to Heroku is essentially the same steps. As long as you can, again, package it into something that's universal, something that's self-contained. Doing it from CI is really no different than doing it from your local machine. We also, on Heroku, we provide like Git integration so you can deploy with Git or from GitHub and just allow Heroku to compile the code for you. Although we are not a CI server, though, so we don't run your tests. Yeah.
You talk about sticky sessions, and by the way, I was wondering if you had any experience with helping teams that use sticky sessions, or try to make something to affect that approach, or make that transition?
Yeah. It really, I think it comes down to embracing the other principles. So, it always ends up being like you need to use memcached or some other external service. And as long as you're capable of attaching those services just simply through a URL, it becomes easier to implement that. It has been a struggle, though, and ultimately we do support sticky sessions on Heroku because people need them, people use them for better or worse. But yeah, I think that a lot of these principles are really integrated, and so embracing some of them makes it easier to embrace others.
So, often in order to scale out, you basically partition your data. Then you have what you want to do consistent hashing and affinity now. This calls to this node because the data is there. How do you deal with that?
Are you talking about like zero downtime deployment, or where you would?
Well, let's say that you partition your data based on, let's say, dates. Dates in the location, making a simple example. So all the ones that are January 1st should go to a certain place where the data for January 1st is. So it deploys 365 of those scale.
Yeah.
Now, something